Welcome to this informative video on the topic of statistics. Statistics is a branch of mathematics used to summarize, analyze, and interpret data. It plays an important role in decision-making, and can help individuals and organizations draw conclusions from data in order to better understand and act upon it. Statistics has two main branches, descriptive and inferential. Descriptive statistics summarize data into simple summaries such as averages or proportions. This type of statistical analysis allows one to find patterns or trends in the data without making any assumptions about the underlying relationships between variables. For example, if one wanted to know what percentage of Americans earn more than $100,000 per year, they could use descriptive statistics to quickly answer that question. Inferential statistics makes assumptions about the underlying relationships between variables and uses them to make predictions or draw conclusions. This type of statistical analysis is useful when one wants to test hypotheses or make decisions based on data. For example, if one wanted to predict which consumers are most likely to purchase a certain product, they could use inferential statistics to do so by looking at correlations between different factors such as age, gender, location, etc. There are several types of techniques used in statistics, including probability theory and sampling techniques. Probability theory helps researchers calculate the likelihood that certain events will occur given certain conditions or assumptions made about the underlying data being studied. Sampling techniques allow researchers to draw conclusions from small datasets without having access to all of the relevant information. Statistical software packages exist which allow users to apply various statistical techniques with relative ease. These packages can be used for both descriptive and inferential analyses depending on the needs of the user. Additionally, there are numerous online resources available which can help users learn more about different types of analyses as well as how best to use them with their own datasets. Welcome to the world of statistical analysis. Knowing how to properly analyze data is an invaluable tool for any professional. It can be used in a variety of fields such as business, finance, engineering, and even healthcare. In this instructional video, we will provide an overview of 4 key statistical analysis techniques that you can use to make informed decisions about your data. The first technique is descriptive statistics. Descriptive statistics are used to summarize data in easy-to-understand ways, such as a mean or median. This technique allows you to quickly gain an understanding of the overall trends in a dataset and identify any outliers or extreme values that may be present. Descriptive statistics can be used to calculate measures of central tendency such as the mean, median, or mode, as well as measures of variability such as the standard deviation or range. The second technique is inferential statistics. Inferential statistics allow you to draw conclusions about a population based on a sample taken from that population. This technique can be used to answer questions such as, is there a statistically significant difference between two groups? Or, what is the probability that one group is larger than another? To answer these questions accurately, it is important to use appropriate tests such as t-tests and chi-square tests. The third technique is regression analysis. Regression analysis allows you to estimate the relationship between two variables in a dataset and determine how changes in one variable are related to changes in the other variables. It can be used for predictive modeling so that future outcomes can be predicted based on known information about past events or trends. Finally, the fourth technique is hypothesis testing. Hypothesis testing allows you to test whether or not your assumptions about a population are true by using statistical methods. The process involves formulating a hypothesis, your assumption, then relying on specific tests and formulas, such as Student's t-test, to measure if your hypothesis holds up under scrutiny or if it needs further refinement/testing before being accepted as fact. In conclusion, understanding how to use statistical analysis techniques properly can help you gain insights into your data that would not be possible without them. With practice and patience, you too can become a skilled analyst of data and make informed decisions based on your findings. Hello and welcome to this tutorial on descriptive statistical analysis. In this tutorial, we will cover the basics of what descriptive statistical analysis is, its purpose, and discuss some common techniques used in this type of analysis. Descriptive statistical analysis involves using quantitative or qualitative methods to summarize a data set and draw conclusions from it. Its purpose is to provide meaningful information about a population or sample by summarizing key characteristics in a meaningful way. It can also be used to compare different groups within a population or sample. The most commonly used techniques for descriptive statistical analysis are measures of central tendency and measures of dispersion. Measures of central tendency help summarize the distribution of values in a data set by providing information about its center, or average. Examples include the mean, median, and mode. The mean is simply the average value of all values in the data set, the median is the value that divides the data into two equal parts, and finally, the mode is the most frequently occurring value in the data set. Measures of dispersion provide information about how spread out a data set is by giving an indication of how much variation there is between values. Examples include range, variance, standard deviation, and interquartile range, IQR. The range is simply the difference between the highest and lowest values in a data set, variance measures how far each value deviates from the mean, standard deviation gives an indication of how much variation there is in relation to the mean, and IQR measures how spread out values are relative to each other by looking at their quartiles, 25th percentile, 50th percentile, 75th percentile. Other common techniques used for descriptive statistical analysis include frequency distributions, which show how often different values occur, box plots, which show details about a distribution, histograms, which show frequency distribution graphically, scatter plots, which show relationships between variables, correlation coefficients, which measure correlation between two variables, regression analyses, which look at relationships between variables over time, and more advanced techniques such as factor analyses, which identify underlying factors that explain variability in a dataset, or cluster analyses, which group similar objects together. In conclusion, descriptive statistical analysis gives us insight into important characteristics within a population or sample by summarizing key features through quantitative or qualitative methods such as measures of central tendency and dispersion, as well as other common techniques like frequency distributions, box plots, histograms, etc. We hope you enjoyed learning more about this topic. In this video, we will discuss inferential analysis and how to use it in the data science process. Inferential analysis is used to draw conclusions about population parameters from a sample. In other words, it's used to make inferences about a population based on the data from a sample. The primary goal of inferential analysis is to estimate population parameters from samples. It allows us to make educated guesses about populations without having access to all of the data. This is especially helpful when the population is too large for us to easily collect data from every member of the population. There are a few key steps that need to be taken before you can use inferential analysis. First, you need to define your sample by specifying which members of the population you want included in your sample and how they were chosen. Second, you need to choose an appropriate statistic or measure that best describes your sample. Third, you need to compute the statistic and compare it with other samples if available in order to determine how closely your sample represents the population at large. After these steps have been completed, you can then begin making inferences about the population at large based on your sample statistics and measures. To do this, you will need to use a hypothesis test such as chi-square or t-test in order to determine whether or not there is sufficient evidence in your sample that suggests that its statistic or measure is representative of the larger population parameters or not. If there is sufficient evidence, then we can conclude that our findings are statistically significant and thus our conclusions about the population can be drawn with confidence. Now let's look at an example of using inferential analysis in practice. Suppose we have a survey asking people about their satisfaction with their current job situation and we want to determine if that satisfaction level differs across different age groups, 18 to 25, 26 to 35, 36 to 45. We could then take a random sample from each age group and compute a satisfaction score for each age group based on responses from those surveyed within each group. We could then use an appropriate hypothesis test such as chi-square or t-test in order to compare our results across each age group and conclude whether or not there is sufficient evidence that satisfaction levels differ across age groups. If so, then we can draw conclusions about our overall job satisfaction levels across different age groups with greater confidence. Then if we had only conducted one survey covering all ages at once without taking into account any potential differences between them due to age grouping separately. In summary, inferential analysis allows us to make educated guesses about populations without having access to all of the data by taking random samples from those populations and using appropriate hypothesis tests such as t-tests or chi-square tests in order to compare results across different variables and draw statistically valid conclusions about those populations at large based on those results, with greater confidence than otherwise possible without using inferential analysis techniques. We hope this video has been helpful in explaining what inferential analysis is and how it can be used effectively in data science processes. Statistics jobs are some of the most in-demand roles in the world today. Companies need statisticians to analyze data, develop models, and make predictions about their business decisions. As a result, salaries for statisticians vary widely depending on the individual's experience, education level, and specialty. In general, entry-level statistics positions are offered with salaries ranging from $40,000 to $55,000 per year. At this level of experience and expertise, job duties often include analyzing data sets to identify patterns and trends and conducting basic statistical tests. Additionally, those at this level may be responsible for creating simple graphs or charts to illustrate the results of their analysis and present them to decision-makers. At the mid-career level, with around 5 years of experience, salary offers increase significantly, up to $75,000 per year or more, depending on job responsibilities and geographical location. At this stage in a statistician's career, they will likely be expected to use advanced techniques such as modeling or forecasting to inform business decisions. They may also be required to work with larger or more complex datasets than in entry-level positions. For those with even more experience, over 10 years, and specialized skill sets, such as expertise in Bayesian statistics or machine learning, salaries can jump even higher, into 6 figures for some positions, depending on who's hiring and where the position is located. In addition to performing their own analyses from source data collected from surveys or proprietary databases, they may also be called upon as technical consultants on projects within their respective field of expertise. Finally, at the executive level, 15+ years of experience, senior statisticians can command salaries up to $150,000 or more annually at some organizations if they have specialized skills that are highly sought after by employers. Those working at this level might be called upon for analyzing large datasets from multiple sources simultaneously, developing complex algorithms, training others how to use statistical software, reviewing research papers, leading cross-functional teams, developing cutting-edge methods for solving unique problems, and presenting results at conferences or industry events. Overall, there is no one-size-fits-all when it comes to salary expectations for statistics jobs. The range depends on several factors such as job responsibilities, educational qualifications/certifications held by the individual candidate, relevant industry experience gained while employed in other roles over time, etc. But generally speaking, it is possible for a skilled statistician with enough relevant educational qualifications/certifications under their belt, plus a few years of hands-on industry experience under their belt, to command a salary ranging anywhere between approximately $40,000 to $150,000 annually, depending on many factors mentioned above.